Today I am going to discuss one simple topic in data science called correlation. Correlation is a statistical tool. It's used to study the relationship between the two variables, and also it is used to understand the economic behavior of that particular variables. So here, for example, if two variables are said to be correlated, means what changes in one variable can cause the changes in the another variable. For example, price of commodity leads to the cost in the quantity demanded. And also one more example, here the employees' salaries increases and the outcomes also increased. Next, the significance of the correlation means correlation determines the degree of correlation of that particular variables, and which is also used to find out the economic behavior of the variables. So correlation is a statistical tool which is used to study the relationship between the variables. Here, which is also used to define the understanding of economic behavior of that particular variables. Here, for example, if two variables are said to be correlated, so if there is any changes in one variable causes the another variable. So for example, the price of the commodity leads to the quantity demanded, and also another one example is increases in salary of employees that gives the outcome as a best outcome. So here the significance of correlation, first it defines here the correlation which is used to determine the degree of the correlation, and next which is used to understand the economic behavior of that particular variables. And if two variables are correlated with each other, means one variable can be evaluated or calculated by using the another variables. And one more thing which is used to taking the correlation is used to taking the decisions better, and also which is used to handle the uncertainty situations. So here it gives the values as in a real manner. So next we are going to discuss about the types of the correlations. So here the correlation which can be classified into three. One is the positive and negative correlation, and the next one is the linear and non-linear correlation, and the next one is the simple, multiple and partial correlation. So positive means here the correlation that is a changes in same direction means that is said to be same direction means here this correlation is said to be a positive correlation. And here negative correlation means here the changes in opposite direction means that is said to be a negative correlation. So for example, for a positive correlation, here the demands of that rice. Demand of rice increases means here the cost of the rice also increase. That is the same that here the changes in one value that in the changes in another value. Next we are going to discuss about the types of correlation. The first type, here the correlation is categorized into three. One is the positive and negative correlation, linear and non-linear correlation, simple, multiple and partial correlation. So positive correlation means here that can be the values that can be moved in same direction. That is one value that can be changed according increases means and the other values also increase and vice versa. So example, demand of the rice and increases means the cost of the rice also increased. And the second one is negative correlation. Negative correlation means here the values that can be changed in opposite direction. That means one value that can be changed increased and the other value that can be decreased and vice versa. So example is also same thing, that is a temperature as well as the sales of the woolen garments. So here the temperature is increased means the sales of the woolen garments that can be decreased. That is an example of negative correlation. The next type is linear correlation. So these two types are classified based on the ratios of variations that can be changed to the two variables. So linear variation means here there is a variable, here terms that can be varied in a fixed proportion, that is called a linear correlation. So the another type of correlation, which is based on the ratio of variations between the variables. One is the linear and another one is the non-linear. Linear means here the constant change in the amount of one variable. Constant change in the amount of variable due to change in another variable. This is called as a linear correlation. Here linear correlation means when there is a constant change in the amount of one variable due to the change in the another variable. So it forms here, this is the linear variation. So here there is a two variables. This is x variable and y variable. Here the x variable increases means automatically here there is a y variable is also increased. But here the variations that can be in a fixed proportion. So it forms one linear line. It forms a linear line. So this linear line, it represents the relationship between the two variables x as well as y. And the next one is the non-linear one. Non-linear means here there is no constant change in the amount of variable due to change in the another variable. So here it forms here the same thing, here x as well as y. So this here there is a no fixed proportion between the two variables x as well as the y. So here the x variable increases means the y variable is also increased, but there is no fixed proportion. So here the line forms as a curve linear. So this is the relationship between the two variables x as well as y. This is called as a non-linear correlation. So the example is the demand of rice seeds, okay, or seed productions, okay. So here there is no proportion, that is there is no fixed proportion even if you are using double the fertilizers. So this is the example for non-linear correlation. And the next type is which is based on the number of correlations we are using, that can be classified as simple, multiple and partial. Suppose here the simple means what? Means if you are using only two variables, here we are going to calculate the relationship between only the two variables, means that correlation is called as a simple correlation, two variables. So x as well as y, or the example is money and supply. So these are all the, here we are only using two variables, either x and y or money and supply. So this type of correlation is called as a simple correlation. Multiple correlation. Multiple correlation means here we are using more than two variables. More than two variables means that type of correlation is called as a multiple correlation. Here for example, here you are going to mention one variable is the production of rice. Production of rice. So here which depends upon the temperature, humidity as well as the fertilizers. So one variable that depends upon the multiple variables. So more than two variables you are going to use. So one it represents the relationship between the multiple variables, means that type of correlation is called as a multiple correlation. Then what do you mean by partial correlation? Here the partial correlation means here only the two variables can be used. For example, production of rice, that is one variable, and one more variable depends upon the quantity of fertilizers. Okay, so the remaining two variables that can be considered as a constant, means this type of correlation is called as a partial correlation. Okay, so the next we are going to discuss about the degree of correlation. So the next topic is degree of correlation. So here it is also which is used to calculate the correlation coefficient. So which is it is a measure to calculate the relationship between the two variables. Okay, so here the ranges of this correlation coefficient is -1 to +1. So here the sign represents either it is a positive or negative correlation. If it is a minus means that represents the negative correlation, and plus value means that represents the positive correlation. So here it is a number between -1 to +1, and that describes the relationship between the pair of variables. So it is represented here, the correlation coefficient that can be represented as r, small r. Okay, it describes the linear relationship between the pair of variables. Okay, so now we are going to discuss about the significance of this correlation coefficient. Here there is a two values, right? -1 as well as +1. So here the sign value represents the correlation which we are using. -1 which is used to represent the negative correlation, and the +1 which is used to represent the positive correlation. So here the correlation R that can be represented by using with the help of by using one named the honor of British scientist named Carl Pearson. Carl Pearson. So here this coefficient is also called as a Pearson coefficient. So this coefficient is also called as a Pearson coefficient. The sign of the correlation coefficient which represents the positive or the negative relationship between the variables, and the numerical value of this R represents the strength of the linear relationship. If it is the maximum value means it represents the strong correlation, and if it is a less value which is nearer to 0 means which represents the weak correlation. So the number with the plus sign indicates a positive relationship, and the minus sign indicates the negative relationship. A value of R approaches either -1 or +1, then it is a stronger relationship. Which is very closer to 1 means it is said to be a stronger relationship. If the value is very closer to 0 means which is said to be a weaker relationship. Now we are going to see how to calculate this correlation coefficient. So by using the computation formula, here R can be calculated by R is equal to SPXY divided by root of SSX and SSY. Okay. So SPXY which represents the sum of squares. So here this denominator are defined as SSX. SSX means sum of square of x values, and SSY means sum of square of y values. So x can be calculated by using summation of x minus x bar the whole square, and which is equal to summation of summation x square minus summation x the whole square divided by n. And for sum of square of y, which is represented as summation of y minus y bar the whole square. So which is equal to sum of y square minus summation y the whole square divided by n. So sum of the SP means it is nothing but sum of the products. So which is represented in the numerator. So here which is calculated as SPXY, which is equal to summation of x minus x bar into summation of y minus y bar. So which can also be calculated as summation xy minus summation x into summation y by n. So these are all the calculation parts. Once again, here the computation formula which can be used to calculate the correlation coefficient R is equal to SPXY divided by root of SSX into SSY. So SP means nothing but it is the sum of the product. SS means which is nothing but the sum of squares. So SSX is equal to summation x minus x bar the whole square, and also equal to summation x square minus summation x the whole square divided by m. SSY is equal to summation of y minus y bar the whole square, which is equal to summation y square minus summation y the whole square divided by m. So here the sum of product which can be calculated by using this formula, SPXY is equal to summation of x minus x bar into y minus y bar, which is equal to summation xy minus summation x into summation y divided by n. Now we are going to see one problem by using this correlation coefficient. Now we are going to discuss one problem for correlation coefficient by using the computation formula. The problem is, couples who attend a clinic for first pregnancy are asked to estimate the ideal number of children. Given that x and y represent the estimates of females and males respectively, the results are as follows. So calculate the value of R. By using computation formula. Okay. So this is the given data. So by using this data, we are going to calculate the value of R by using computation formula. So the computation formula for calculating correlation coefficient R is equal to SPXY divided by root of SSX into SSY. Okay. So here already we know, so how to calculate SSX as well as SSY. So where SSX, which is equal to summation x minus x bar the whole square. Okay. So SSY means which is equal to summation y minus y bar the whole square. So for that thing, we have to first calculate what is the mean value of x and the mean value of y. Okay. So how to calculate the mean value? So x bar is equal to summation x divided by n, and y bar is equal to summation y divided by n. So summation x means have to sum up all these values, x values. 4, 3, 1 plus 3, 4, 4 plus 2, 6, 6 plus 3, 9, plus 1, 10, 10 plus 2, 12. So divided by n means the total number of values. So 1, 2, 3, 4, 5, 6. So 6 means the x bar value is 2. So similar to x, we are going to calculate the y value. So summation y, 2 plus 4, 6, 6 plus 3, 9, 9 plus 2, 11, 11 plus 11 plus 3, 14. So which is equal to 14 divided by same number x. So the value is 2. So what is the y bar value means? The value is so here the value is 14 divided by 2, that is 2.3. Got it? Okay. So we can also calculate another one example, which is equal to summation x square minus summation x the whole square divided by n. Here also the same thing, y square summation y the whole square divided by n. So which is, I think it is very simple. So first for that we have to first calculate the x square value as well as y square value. Okay. So 1 is 1, 3 square is 9, 2 square is 4, and 9, 1, 4. Here 4, 16, 9, 4, 0, 9. So summation of this value is summation x is equal to what? 12. So here you can write summation x is equal to 12, summation y is equal to 14, summation x square is equal to how much? 10, 14, 15, 15, 24, 28. Summation y square is equal to 20, 29, 30, 33, 33, 42. Okay, so now you got all the values, right? Now you have to substitute the values here. Okay, summation x the whole square. Summation x square means what is the summation value? 12 square minus summation x the whole square. So summation x square means 28. 28 minus 12 square divided by 6. Okay, so what is the answer? 28 minus 144 divided by 6. So 144 means 224. So the answer is 4. So first x value is equal to 4. Okay. Now we have to calculate the SSY. SSY is equal to summation y square minus summation y the whole square divided by n. So summation y square value is 42. So 42 minus summation y the whole square. What is the summation y value here? 14 square. So 14 the whole square divided by n means 6. So I think here the value is 9.34. 9.34. Okay. So here the denominator values we got. Now you have to calculate the numerator value, that is the product, sum of products. So SPXY. So the SPXY which is equal to what is the formula for SPXY? Summation XY minus summation of XY divided by n. Right? Summation x into summation of y into n. So here you have to add one more column called xy. Right? 1 into 2, 2, 3, 4, 12, 3, 2, 6, 3, 2, 6, 0, 6. So here the sum of these values 12, 8, 12, 12, 24, 24, 26, 32. So here the 32 sum is here, right? Summation xy is equal to 32. So 32 minus 12 into 14 divided by 6, which is equal to 32 minus 2, 28. So SPXY is equal to 4. Got it? Okay. Now you have to substitute all these values into correlation coefficient, which is R is equal to, so SPXY, what is the value of SPXY? 4, which is divided by root of 4 into 9.34. So which is equal to 4 divided by root of 37.36, which is equal to 0.6546. 0.6546. Okay. So here the R value is, the final R value is equal to, the final R value is equal to 6546. Okay, so here, this is here the sign of the correlation coefficient is the positive. So here there is a positive correlation between the two variables x as well as y. And also one more thing you have to consider, it is here the value is very closer to 1. Okay, so here the correlation between these two variables is strong. So it is a positive as well as strong correlation between the two variables, that is x as well as y. That's all about the problem. The next topic is regression. So regression is a supervised learning model which is used to model the relationship between the dependent as well as the independent variables. And here the regression, which can be mainly used to predict the continuous variables. So here, for example, here we are going to, by using this regression, we are going to predict the house values, okay, and also the stock prices. So what is the need of this regression means, here the regression which is mainly used to estimate the unknown outcomes. For example, unknown outcomes means salary prediction based on the experience as well as the performance. So we don't know what is the predicted salary. Okay, so by using this regression, we can predict that corresponding unknown outcome. And the next one is predict future values. Nowadays, you know the price of gold. Okay, so that can be varied. So by using this regression, we can predict the future values of that gold and also the houses and also the stock prices in turn. Okay, and the next need is decision making process. So here, which is mainly used in the business, which is made to make the proper decisions in a critical situations and also in uncertainty situations. So for that purpose, we are using this regression. So these are all the need of using this regression process. So here the regression that can be calculated by using least linear square regression line. So here the calculation that can be represented by using regression line formula, that is nothing but y dash is equal to b into x plus a. So here the b as well as a that can be called as the coefficients, and the y is called as the independent variable. Sorry, y is a dependent variable and x is the independent variable. Y is the dependent variable and the x is the independent variable. And a comma b, which is called as a coefficients or constants. So here these two values can be calculated by using the correlation analysis. So the b can be calculated by using the formula r into root of SSY divided by SSX, and a can be calculated by the formula a bar y minus b into x bar. So these are all the formulas that can be used to calculate the regression line. By using this regression line, we can easily predict the future values, unknown values, and also based on that values we can make the decision making process. Okay, now we are going to one small example problem by using this regression. So here assume here the correlation analysis that can be given as a correlation coefficient. Here the R value which is represented as R is equal to 0.30, which is used, which is the correlation between educational level as well as estimated number of hours spent reading each week. So here the values that can be given for educational level as well as the reading time, that is the two variables, x as well as the y variable. So y is the independent variable and x is the sorry, y is the dependent variable and the x is the independent variable. So these two variables that can be given, and also the correlation between these two variables also given. So now we are going to calculate the regression line. So the formula is y dash is equal to bx plus a. So before that you have to calculate first b as well as a value. So already you know the formula, b is equal to r into root of ssy divided by ssx. So already the values are given. So first calculate b value. B is equal to, r value is 0.3 is 0. So root of, so what is the ssy value? 50 divided by 25. So which is equal to 0.30 into root 2. So which is equal to, the value is 42. So here the a value can be substituted in here b value that can be substituted in a. So the a is equal to y bar minus b into x bar. Already you know the x bar value as well as y bar value that can be substituted here. So 8 minus 13 into 42. So a is equal to 2.54. Sorry, here the value is 0.42. Okay. So now we got two values. A is equal to 2.54 and b is equal to 0.42. So I have to substitute these two values into the equation 1. So the y dash value becomes y dash is equal to 0.42x plus 2.54. So this is the final regression line formula by using linear regression, linear least square regression method. By using this, we can also easily predict the values for the another one. For example, suppose if you want to calculate Faith's education level is 15. What is her predicted reading time? So here Faith's education level means that is the x value is given. So you have to predict the value y. So you have to apply this value into this equation. So y dash is equal to 0.42 into what is the x value? 15 plus 2.54. So you will get the value as 8.84. This is the predicted reading time of Faith. Y dash is equal to 8.84 seconds. So this is the predicted time of reading. Predicted reading time. Okay. And also one more problem, that is Kagan's educational level is 11. Okay. Kagan's education level is 11. And what is his predicted reading time? Means you have to simply substitute y dash is equal to 0.42 into 11 plus 2.54. So you will get the Kagan's maximum reading time. So which is equal to 7.16. These are all the predicted values or predicted reading time value of Faith as well as Kagan. Okay. So regression, which is mainly used to predict the values